All right, so I'm going to add another utility here. This one is going to actually be something I don't display. So this is how you do it in Greenfoot, is you can create a new class here. So if I create my new class, this one is going to be a location. You might end up finding this useful in many of your future projects as well. Basically, it keeps track of the X and Y coordinates in one convenient place. So Greenfoot tries to be helpful to you. It tries to fill in as much as it can, but we don't need all this stuff here. I'm going to delete a lot of these example things. And this is basically a container, so let me show you what that looks like. I'm going to store an X coordinate, a Y coordinate, and that's how you build a location. You need to tell me what is the location you're at, and I will keep track of it for you. So the instance variable is going to be X and the Y you give me. Now again, if you find it's more readable to do this, you can say give this object the X and Y that start this class off in its constructor. So all I want to be able to do here is once you give me a location, I want to be able to ask about it and possibly change it. So here's the methods. So get the X, I will just return that X coordinate to you. And again, if you find it more readable, there's nothing wrong with doing that. Java does it for you if you don't. So now if you want to know where this object is located, you can ask for the X and Y. But we're going to use this in a minute here. So I'll finish off these methods. So this is going to be my X coordinate is the new X that you just gave me. And I've given you a mechanism to change them. So one thing that's going to be handy for us when we deal with locations on the screen is we might want to know if this location is, for example, the same as another location. So what I'm going to do is create a method that tells me yes or no whether or not these things are equal. So two locations are equal. Listen to my English for a sec. If their X coordinates are equal and their Y coordinates are equal, that means they're in the same spot. But in Java, it sounds very similar. If this X coordinate is equal to the other's X coordinate, and other is this location I'm testing it against, and this Y coordinate equals the other Y coordinate. So if that's the case, I can return true. They are the same. If that's not the case, they couldn't be the same, so I would return false. And I'm only going to add one more method to this. We don't do it, we won't use it in this project, but just because this class might be helpful to you in later ones, I'm going to show you how to write a method for the distance between 2 points. You may have done this in your math class already. But if I want to know how far apart 2 points are, that's a Pythagorean thing, where you go like this and say the distance between the x's is this x minus the other x, and the distance between the y's is this y minus the other y, and the distance between them is the square root of the distance, the x distance squared plus the y distance squared. So if you haven't learned it in math class already, It'll be coming at you at some point, but this is the distance between 2 points on a graph. The square root of the x distance squared plus the y distance squared. We got time for a quick little math lesson. If this is my x, I'll call it x1, y1. This is my x2, y2. If I want to know how far apart they are, I'm going to build a triangle, which means that distance is the change in those x's squared plus the change in those y's squared is that distance here squared. So we went like this, took the square root to figure out how far apart they are. It's useful sometimes, like if you're building a villain that goes to like the closest location or the farthest or something. But anyway, that's our location class. And I'm going to use this to create what I'm going to call a goal mover. So this will be an object that moves towards a particular location. So you may want to use this class in yours as well. But basically, this is an actor that is going to walk towards a goal. So it needs to keep track of where that goal is. And when you start, I'm going to say there is no goal. You're going to have to tell me where you want to go. So I'll say public void set a goal. So goal equals this location. That'll give me a target to move towards. Okay? So I'm going to walk through how this would actually act, but this is all the goal movers will do. You say, I'd like you to target this position, and it'll move until it gets there. So that's the kind of acting that I'm going to do, is I'm going to see if I'm currently at my goal. If I don't have a goal, I won't do anything. So first thing I will check here is if my goal is null. That's a sad state of affairs. We don't have any goal. So I wouldn't do anything. So what I'm going to do instead is say, let's be a little happier. If we have a goal, now we can talk about what we're going to do. If we have a goal, I should check, am I at that goal right now? So if the place that I'm at equals that goal, then there's nothing for me to do. I'm at my goal. So the only time I'd have to go into action here is if I'm not at my goal. I need to keep moving. So I'm going to make a method for that. Move towards my goal. So this is what a goal mover does. If it has a goal, it's going to check, have I gotten there yet? If I haven't gotten there, it'll move towards it. So thinking about that, I'm going to give another method here. If I've reached my goal, I think I'd like to know about that. So I'm going to say there's my current location. And if I've reached my goal, then where I'm at is equal to my goal. So now I can use this here. It's a little more readable, but it will come up later. If I have not reached my goal, keep moving. So let's write that method here. Public void move towards goal. Now when our characters are moving, they have a particular speed that they've been moving at. So that's one thing I'll want to know here is what speed should we move towards the goal. So to move towards the goal, I'm only allowed to use that speed for left, right, up, down. And that means I need to ask Java some questions about how I'm going to do this movement. This is a class that, again, it'll be available for you to reuse, but it's worth seeing how it gets written. This would be something you could do near the end of the course. So for now, if you're just hanging by a thread, I understand that. This is not your expectation to be able to reproduce this by yourself. But I need to know if I'm going to move left or right. So that's what I'm going to do here is I'm going to go, what's my x change? So first I'm going to figure out, should I move left or right? And what I'm going to do is say, take my x, and I'll show you here what's going through my mind. If this is my actor, and it has an x and a y, and this is my goal x and my goal y, what I'm going to want to know here is, what's the difference between them? Okay, so I'm going to take that goal x minus that x, and I'll use that to figure out if I'm moving towards the left or right. And I'll do the same thing for up or down. Oops, sorry, that's the... So this time, if I wanted to know the difference between these ones, the weird part again is that down here is going to be positive y. So I'm actually going to go goal y minus y as well. So now I'll make my decision here about what I'm going to move them. So if the x change is less than 0, that means I need to move left. But I can't move by more than the speed I was given, and I don't want to go past the goal if I'm about to reach it. So that's all I'm going to check here is if the x change that I need to move by is greater than or equal to the speed. Sorry, I'm going to do this backwards here. If the speed that I move is greater than or equal to how far I'm supposed to move, then I'm going to say just move by that exact change. So will hit the correct x. Otherwise, the x move is going to be equal to speed. Since it's moving left, it'll be a negative. Okay. So very similarly, let's see here. This time my speed is greater than the amount that I need to move, so I will move exactly that much. This time, since I'm going to the right, it can just be the speed I was given. So one thing I'm noticing here is this should be a negative of it, because the change is to the left. Since the change is negative, the speed would always win. So I'll leave it at that. And I'm going to do the exact same thing for what the Y move would be. So this just figures out how much I'm allowed to move in the X direction, and this one figures out how much I'm allowed to move in the Y direction. And of course, the danger with copy and paste is that you miss one of these changes. So we'll have to go through it before we're happy with it, but let's just start with that. It's the same logic, but now we have to think about it up and down. So in this case, if the Y is negative, it's going to be moving this way. It's moving up. And the speed that I'm moving, if I can beat that distance, that's as far as I want you to move, exactly by that distance up. So far so good. Otherwise, I can only max out by the negative of that speed. You can only go up by that maximum of the speed you give me. So now that I've got all my speeds in here, and my change, if it was positive, this should work too. It's moving down this time. I can update where the goal mover will go. So set its location to be where it is now, plus how much the X moves, and plus the Y move. So this will move towards that goal. And we'll try this. We'll get it up and running here. Okay. So I'll add a slightly different method to this as well. Another convenience thing that you may find useful when you use this class. You may just want to know those coordinates. So if I just give the coordinates, that means I need to build this location. And that's how I'll do this one with my goal mover to demonstrate it. Okay, so we can compile this. Probably going to have to make an edit here. I'm not feeling super confident with the amount of lines of code I wrote. Okay. It should be goal. And we'll see how I do this time. So the move towards goal, it's the speed with which that I would be moving that I don't have here. Okay. So that's one of the things, unfortunately, that we'll have to program in until we have some better techniques. So now that I'm going to keep track of the speed, I'll just use the one that I've given the instance variable. And hopefully that'll be a good fix for now. Okay, so now I can show you the way a goal mover is supposed to work, just so you can understand why that might be useful to you. I'm going to just create a fake one here before I do anything purposeful. I'll just set up an animal to do this. So I'll put an ant in space, maybe a bee, it'll be easier to see. But now this bee, I want it to act the same way that the goal mover does, because that's why I've built it. So the only edit that I'm going to need to do to the code is I just want you to act like your parent. Otherwise, we've redefined everything, and you won't see that happen. So nothing's going to happen to space B, because we haven't set a goal yet. So if I now go here and say set the goal, the middle of the screen here, it's going to be something, I think it was 800 by 600. So let's try that and see if it moves itself towards there. But now it should have a goal that I'll be able to program it to move to. So just give it a second, it's a little laggy. So now the bee moves, and once it gets to its goal, it stops. So this again could be like an enemy chasing you. You give me the location of your hero, and I target your hero. It could be like maybe it's food, and you're saying the ant I've built is going to move till it hits the food. But again, I'm going to give you this class and expect that you just use it the way I did with the bumblebee.